Winter has arrived early. Cold Arctic air across the whole of the UK during the next few days, with some very specific parts of the UK affected by some very significant amounts of snow. And before I go any further, I want to emphasise that it's the North York Moors and the Yorkshire Wolds where we are most concerned about impacts from snow, particularly this coming Thursday. If you are concerned about that part of the UK, head to the Met Office website and app for the latest weather warnings. There are numerous weather warnings across the UK for snow and ice during the next few days because of a mixed wintry picture. But for many places away from those specific areas that will see significant snow, there'll be hardly any snow. And I'm going to detail which areas are expecting the significant snow and which areas will hardly see any during the coming days in the next 20 to 30 minutes. In this Met Office Deep Dive, welcome along. We do these every Tuesday. And if you enjoy watching these in-depth weather reports, please do hit subscribe if you haven't already. Send us a like, send us a comment, send us a question. We try and answer your questions in the Weather Studio Live, which is another YouTube video that we do at lunchtime on a Friday. And that's more interactive. You can join those live and ask us questions, or of course you can post your question in the comments afterwards. So send us some love if you enjoy these longer form weather forecasts. And there's certainly a lot to pack in this week. At the time of recording, Tuesday afternoon, we do have an Atlantic system crossing the UK, bringing a messy mix of rain, sleet and hill snow initially to northern parts of the UK, but that's going to be spreading south overnight and into the start of Wednesday, and I'm going to be looking at that in just a moment as well. This is the mixed precipitation radar, so it shows whether what's falling out of the sky at the moment is rain, highlighted in blue, or sleet or snow or hail, highlighted in white. And you can see this is early hours of Tuesday. We've got the system moving in, bringing that mixture of rain, sleet and hill snow to northern England, Scotland, parts of Northern Ireland before sinking south. But actually, last Friday, we were studying the radar carefully because of the rain, and that was the major talking point. And I just want to spend 5 to 10 minutes or so looking at the system, Storm Claudia, that brought us so many impacts from rain, particularly the town of Monmouth. Of course, you'll have seen the devastating images of flooding in Monmouth because of the exceptional amount of rain that parts of southeast Wales saw in particular. And the meteorological setup, whilst devastating in some places, was fascinating in terms of how it all worked together, and I'll explain why now. On Friday, this is the radar. This is through 6 a.m. Friday to 6 a.m. Saturday. And what you can see is from the word go on Friday, these bands of heavy rain moving north across the UK, but they're not clearing north. They're stalling. The northern edge isn't changing. It's across northern England there. Whilst they're bunching up, these bands of rain are bunching up across parts of Wales, the Midlands in particular, and the brighter colours indicate where we saw particularly heavy and persistent rain. So effectively, we had this weather front moving up and stalling across this central swathe of the UK and becoming increasingly intense through the day. You can see as we run through the day on Friday, some really quite heavy showers and longer spells of rain developing across parts of Wales, the Midlands, the southwest of England in particular. And in fact, if I skip forwards to 1500, this is the picture at 1500. Now, Scotland and Northern Ireland escaping mostly dry. We've got these showers coming into the northeast of Scotland, but otherwise dry. Something a little drier along the south coast of England, but at this stage at 1500, we've got some heavy thundery downpours moving into parts of Devon. In the middle, this band of very intense, very prolonged rain with the brightest colours there across southeast Wales. And the meteorological setup, as I mentioned, behind this was really quite extraordinary, and I want to show you why. A couple of charts I'm going to show you have been shared by Matthew Leonard, one of our chief meteorologists who was on duty last week and did an amazing job at forecasting the setup and the impacts from it, but also shared these charts with colleagues, and I just want to show you what was going on, because this is showing the same time, 1500 on Friday, and it shows where the air was coming from across two extreme parts of the UK. So here On the left, we've got Scotland, northern Scotland. Where was the air coming from? Back trajectories show the air came right the way from the North Pole on Friday across northern Scotland. So the Arctic air was in place already across northern Scotland, directly from the North Pole. This on the right shows the source of air for the south of England. I think it's pointing to Exeter there. And the source of air for the south of England was North Africa via Spain, and some bits of air coming from the Mediterranean, but a lot of the air coming from North Africa. So we've got this clash between air coming up from North Africa on the one hand into the southern half of the UK, and air coming all the way down from the North Pole for the northern half of the UK. And when you get these two air masses colliding, that causes some significant impacts because of the enhanced, what we call the thermal gradient, the enhanced difference between cold air in the north, warm air in the south. And this is really visualized very well by looking at a cross-section of the atmosphere, slice through the atmosphere. And again, Matthew Leonard provided another chart that shows this slice through the atmosphere. Imagine taking a slice of the atmosphere along 2.5 degrees west, so that's roughly the Wales-England border up to Dumfries and out towards the north of Scotland. And you're taking this slice of atmosphere all the way from the Arctic Circle down to the south of France. So it's about there. Imagine taking 2 points and having a cross-section through the atmosphere, and that is indeed what we're able to look at here. And at first, I know this is going to look thoroughly confusing. It took me a while to get my head around it as well. There's lots going on in this chart. It's highly technical, but if I just explain as we go along some of the key details, it really is quite interesting. On the left here, that's where we've got the Arctic Circle. It's about 70 degrees north. So 2.5 degrees west, 70 degrees north. At the bottom of the chart, that's sea level. So we're running along here into Scotland. Northern Scotland's about here, up towards 57 to 60 degrees north. In fact, might be able to draw here. Yeah, I think I did earlier. There we go. That's about northern Scotland there, and then running further south again. Here we've got North Wales, and here we've got South Wales. So Wales represented by this horizontal black line, and then the south of England about there, the south of France there. So this is a slice from north to south of the atmosphere, sea level at the bottom, and then we go higher in the sky and get up to about 12 or 13 kilometres at the top there, 45,000 feet, something like that. So the jet stream height is at about the top of that chart, around 200 hectopascals, 250 hectopascals. In fact, I'm going to talk about this in a moment, but the jet stream is actually here. It's highlighted by these black lines. So we're looking at slice of the atmosphere. There's lots of meteorological parameters, bit of a tongue twister, met parameters shown on this chart. Now the colours represent something called potential temperature. Not quite temperature. If it was temperature, it would show pretty much getting colder from the surface up to the top. But that's not what we're necessarily interested in when we're looking at the clash of two air masses, because that, well, when it always gets colder as you go higher up, hides a lot of the more interesting characteristics of these air masses. Potential temperature removes altitude from the equation. So basically, when you go higher in the sky, pressure lowers and air parcels get bigger, they expand, and the temperature drops. So you typically see a temperature drop as you go higher in the sky. If you were to take the air from up here, so up at 40,000 feet, and you were to take it and bring it all the way down to the surface without adding or removing any heat to that parcel, then you would you would adiabatically warm it. That's the technical term, but essentially it would come down, there's more atmosphere pressing down on it, it compresses and it warms up. So you take air from up here, take it down to the surface without adding or removing any extra heat, it warms up and its temperature goes from, typically it might be minus 35, minus 40 up here, but it warms up to a different temperature when it gets brought down to the surface. That's what these colours represent, the temperature that air would be if it was brought down to the surface. It's saying 22 degrees up there, so we know that if you take air from up there and compress it down to the surface, it's going to warm up to 22 degrees. The temperatures up here don't really matter. We're looking closer to the surface. This is where all the action's taking place. And what's happening is we've got these blues here. That's the Arctic air. The arrow here shows that's moving south into Scotland, into Northern Ireland. But at the same time, we've got the air from the north of Africa moving north. That's moving this way. These brighter colours indicate warmer air moving north. And along the boundary, we've got a very tight gradient of potential temperature. So this is why we use potential temperature, because this gradient is most highlighted when we use these parameters. So what happens when the cold air bumps into the warm air? This is weather fronts 101. The cold air is more dense. It tends to force the warm air upwards. So the warm air rises over the top. That's what it's doing. It's rising over the top of that cold air which is coming in along the surface. What happens when you lift a lot of warm air, which is, by the way, very moist? That's what this white line here, you might be able to see, it indicates relative humidity above 95%. So it's not only warm, it's very moist, it's full of moisture. What happens when you lift this large amount of warm, moist air into the sky? It cools down and it condenses. And all that condensation leads to clouds and rain and so on, but it also leads to warming of the atmosphere because of something called latent heat release. When you condense something, it releases heat. It's the opposite of evaporative cooling. We all know what evaporative cooling feels like. It feels like that chill when you get out of the shower, the droplets of water on you are evaporating. They're taking energy, heat energy from your skin, making you feel colder. So condensational heating, that is the opposite of evaporative cooling. And when you get this heating, as the air rises, as the warm air and moist air rises and it condenses, you've got here, you can just about make it out, there's like a grey dashed line. That's where you've got so much latent heat release that it's causing the air in this area, and remember this is about the latitude of South Wales, the air close to the surface is expanding. That causes a lot more rising of the air. So the air is really rising quickly here because of the extra heat being pumped into the atmosphere. So that compounds the issue with the warm air rising ahead of the cold front. You've got this extra ascent, this extra rising air, and this extra release of cloud and rain and moisture and so on into the atmosphere. So all the ingredients there for a lot of rain, and of course that frontal boundary doesn't move through the day. So we've got this constant rising of warm and moist air all the way from North Africa as it pushes over the cold Arctic air, all in the same place. Combine that with the condensational heating of the atmosphere and all this air being pushed, being pumped upwards from the surface over southeast Wales. And if we turn our attention to further south, so this is over the Channel or thereabouts, northern France at the same time, we've got here, this dashed line indicates a dip in the jet stream, or dip in the tropopause, not the jet stream. That's the top of the troposphere, so the stratosphere is up here. What that basically means is we've got lower pressure way up high in the atmosphere, what we call an upper trough. That causes air here to rise, leading to those thundery downpours that I mentioned that were pushing into Plymouth and South Devon at about 1500. So we've got that aspect as well behind the frontal rain, so the thundery downpours, the heavy showers. And one final aspect that's going on here, the black lines, as I mentioned, they are what we call isotachs, lines of equal wind speed in knots. And you can see the black lines here, 100 knots up at jet stream height. So this is where the jet stream is, but there's another part of the jet stream over here. The jet stream was a bit all over the place. And you've also got, so you've got this strong wind high up here, but you've also got, if you can just about make out here, just over North Wales and Cumbria, that kind of latitude, you've also got a peak in wind speeds, 50 knots or so, just above the surface, and that's called a low-level jet. So that's where, yes, you've got this big enhanced thermal gradient and a lot of isobars on the pressure chart, for example, but the winds get squeezed over the higher parts of North Wales and Cumbria. These easterly winds were getting squeezed, and you get this peak in winds just above the surface. And we ended up seeing a wind speed of 63, I've got it written down here, 63 miles an hour at Aberdaron in Gwynedd, 68 miles an hour Walcott Range in Cumbria. So that's where that is. And then to the south of that, over southeast Wales, some remarkable rain accumulations. 120 millimetres was recorded between 6 p.m. Thursday and 6 a.m. Saturday at Taflog in Gwent. That was a Natural Resources Wales rain gauge. 81 millimetres Environment Agency rain gauge in Worcestershire. So yes, a lot to get your head around there, but it's such a classic diagram of how weather fronts work, where you've got cold air at the surface and then warm, moist air being forced over it. But this was an extreme example of it because of such contrasts between those two sources of air. But let's move on. Let's move on because now the UK is seeing the cold air become more widespread. It's not just across Scotland and Northern Ireland. That Arctic air is across the whole of the UK. Let's take a look at the setup for the next few days. Here we are at the moment. As I mentioned, we've got a dip in the jet stream just to the northeast of the UK. These weather fronts, this little feature coming south at the moment. And yes, cold air, but not as cold as it's going to get because this Atlantic low has moved in. So initially we had northerly winds to start the week. This low's moved in and it's brought a messy mixture of rain, sleet and snow to many places. And the best way to visualise that is to look at freezing levels. Now, we've talked about this before in the deep dive, and what the freezing levels represent is the height of 0 degrees Celsius above sea level. And meteorologists find it a useful tool to look at freezing levels because, as a rule of thumb, if the freezing level is around 200 metres or lower, then you typically get snow at the surface. But if it's higher, then you need a bit more intensity to the precipitation. So particularly heavy rain or precipitation can cause the freezing level to drop further because the heavier the rain or sleet or snow, the more the atmosphere cools through that evaporative cooling I was talking about. So this is a useful tool for showing where we're likely to see snow, what kind of level, how high up you need to be. And when you factor that in with how heavy the precipitation is as well, that can be a good guide for where we're going to see it. And it's so messy for the rest of Tuesday. Now you can see here that Ireland into southwest Scotland, Western England and Wales, we're in the mild area. It's 1,000 metres plus, so no snow on Tuesday afternoon in western and southwestern fringes of the UK, but much colder across Scotland, much of northern England. And if we go forward to Tuesday evening, you can see that cold air starting to dig south. Now, at the same time as the cold air digging south, we've got that precipitation moving south. And I realise that many people will be watching this whilst this is happening. We've got precipitation moving south, and it's a mixture. You can see across the southern half of England and Wales, it's rain showers predominantly, but further north, it's mostly snow for Scotland. And then this mixture in between, where we do have a gradient in the height of the 0 degree isotherm. So no chance of snow as we go into the evening across the south, but an increased chance further north. And in fact, if we play this forwards, you can see the freezing level is dropping through the night. So that's coming down at the same time as various bands of rain, sleet and snow are coming through. And that means that by the time we get to 1 a.m, for example, here's our band of, a little bit of an occluded front, band of rain, sleet and hill snow. It's coming south. Now, predominantly, this is going to be snow falling at about 100 metres or so above sea level, certainly inland. Around the coast, mostly rain. But you wouldn't rule out, because it's night time, things are cooling off. The wet bulb freezing level, as you can see in this area, isn't far off 200 metres. We've got this gradient from 800 metres in the south to 200 metres across northwest England at this time. So in between, that's where the front is. That's where this occluded front is. and it's ending up quite messy. So a real mixture. I wouldn't rule out, a bit of snow falling on grassy verges as this sinks south. It does move south fairly quickly, but you could get a centimetre or two, perhaps more, over the highest ground across North Wales into the Peak District and Northern England. And by the time we wake up on 6 a.m. Wednesday, that's moving through central southern England, mid Wales, East Anglia and the southeast. And as you can see, again, it is that real mixture of blues and whites. So it's going to be one of those where it will depend on intensity, it will depend on how much these areas have cooled ahead. During the night time, it will depend on the wet bulb freezing level, which again shows that gradient with higher levels across the far southeast, but really digging down quite close to the surface across parts of Wales and central southern England. So just it is a very messy one, a classic example of why it's difficult to predict snow in this country. Some areas here will have rain to wake up to, some areas will have snow. Where you have snow, unlikely to be particularly exciting, but there could be some slippery surfaces here and there, could be some sleet or even wet snow settling on grassy verges, on car windscreens, that sort of thing. It's not going to last long. It does move through, and by lunchtime that feature is out of the way and things become a lot more straightforward, because by Wednesday afternoon we're back into this straight northerly wind across the whole of the UK. And I want to talk a bit more about Wednesday and Thursday's weather now, because it could cause considerable impacts, as I mentioned at the start. Now, here's how things are on Tuesday afternoon. We've got this messy mixture of rain, sleet and hill snow moving south across the UK. But by Wednesday afternoon, that's clearing, and the winds, as you can see from the isobars, are coming straight from the Arctic. So the air that comes south across the UK on Wednesday and remains with us on Thursday is directly from the North Pole. In fact, it's not just from the North Pole. This shows the source of air from several days ago, and it shows it coming originally from Siberia, passing through the North Pole, or the Arctic Circle, and then coming south through the Norwegian Sea into the North Sea and into the UK. And this is where it ends up across the UK on Thursday. So Thursday's air comes originally from Siberia via the North Pole. It doesn't get much colder than that. Even at the start of winter, when things haven't properly cooled off, it's cold enough for some significant snow. But the snow isn't going to affect everyone. It would be cold enough for snow fairly widely, and I'll show you that on this graphic. This again shows the wet bulb freezing levels, the height at which the temperature goes below zero, the height you have to go up in the atmosphere. And this is the start of Thursday, and as you can see, fairly widely, even if we go to Thursday afternoon after the sun's come out and done its warming of the land, you can see fairly widely across the UK that wet bulb freezing level is 200 metres or lower. So the kind of height that you'd expect snow, if you had precipitation, to be falling close to the surface. A little bit higher for Wales and the southwest, coastal parts of Northern Ireland, western Scotland. So around coastal areas, not quite as low, but certainly quite a large part of the UK. The air, because of its source, is cold enough for snow, and that continues into Friday, for example, fairly widely. Again, it's cold air, particularly cold for the time of year. But at the same time, that northerly wind coming through, it's going to be picking up moisture from the sea. The sea temperatures are above average, so cold air coming over warm seas picks up a lot of moisture. You get a lot of instability, a lot of showers. However, if we skip, well, let's go to Wednesday, and we'll turn off the cloud. Those showers are mostly going to be affecting coastal parts, particularly northern Scotland, the east of England, parts of Pembrokeshire, southwest England, Northern Ireland. This is known as a Pembrokeshire dangler. You might have heard of it. It's where the winds, when they come from the north, they funnel together across the Irish Sea and leave a line of showers into Pembrokeshire and these line of showers continue into parts of Cornwall. So this basically summarises which areas are likely to see stuff falling out the sky, precipitation on Wednesday, and more of the same into Thursday. It's these exposed northern and eastern coasts and some of these Irish sea coasts as well as parts of Northern Ireland. And that's why Wednesday and Thursday we're going to see such substantial differences in amounts of snow across the UK. What weather will you experience if you're not getting these snow showers? Simply sunny skies, crisp early winter days, frosty nights. But where we do get these showers, a lot of places are going to see snow accumulating away from coasts, away from right down at sea level where it could be a sleety mixture. Some places are going to see significant snow building up, and we can show that by the snow depth forecast here. So this shows Thursday. Let's go to Thursday evening. And it shows how significant those snow amounts may end up being across the UK. But you can see large parts of the UK, no snow at all. No snow. Piddly amount in some places tonight, then sunny skies for many because we've got the shelter from the showers. But if I zoom in here, then you can see a lot of snow building up inland across northern Scotland, 20 to 30 centimetres in some places. So the Grampians, Northwest Highlands, zooming in a bit more, you can see Northwest Highlands, the Grampians, and then you come further south, not much at all through the central belt, perhaps a little bit over the southern uplands, Pentland Hills. Northern Ireland, Sperrins, 10 centimetres possible, but not much elsewhere. And then coming into northern England, certainly a little bit over the Pennines, but we've got this direct feed of showers across the North York Moors and into the Yorkshire Wolds. And so this is somewhere that we are particularly concerned about. Again, check the weather warnings on the Met Office webpage and app. This area, the risk of 20 to 25 centimetres of snow above a few hundred metres. This area here, that could cause significant impacts on Thursday because of the sheer amount of snow building up over higher parts here. On the coast, barely anything. So real significant differences between what we're seeing around the coast and at low levels and over hills that are exposed to the northerly wind. And one prime example of that, I mentioned the Pembrokeshire Dangler. Look at that, small part of Pembrokeshire seeing snow shower after snow shower and 10 or more centimetres of snow building up there across parts of Pembrokeshire, higher parts of Pembrokeshire. And a little bit over Bodmin Moor, a little bit over Dartmoor, but not much at all. So significant impacts in some very specific parts of the UK by Thursday because of the sheer amount of snow building up, 20, 25 centimetres in places, whilst many parts of the UK see no snow at all, just blue skies, sunshine and frosty nights. And it will feel cold. It will feel really quite cold. Here are the maximum temperatures over the next few days. You can see high single figures at best on Tuesday, even lower on Wednesday, Thursday, Friday. Add in the wind chill, and it makes a significant difference, particularly on Thursday. These are the feels-like temperatures, 2 p.m. Thursday, -1s, -2s fairly widely across the UK. These are the actual temperatures that a thermometer would record because it doesn't have that body heat to lose. So our bodies would feel more like this because we've got that layer of heat that can be blown away by a brisk wind. On that coast, -2 degrees there for Aberdeen, for example. And those temperatures are well below average. These are the temperatures and how they compare with average over the next few days. So several degrees, this is 3 to 6 degrees below average. That's what the darker blues indicate. Today, closer to average in the west. Then we're below average fairly widely beyond that into Wednesday, into Thursday, and so on. Likewise, minimum temperatures really quite low compared with average. Thursday morning, Friday morning, Saturday morning, and then some recovery into Sunday morning. Why is that? Just to touch on the change into the weekend. We've got those northerly winds in place on Thursday, but the Atlantic is starting to get a bit more oomph. This low pressure is moving away. Here's Friday, starting to see a transition. Friday, certainly a widespread frost to start things off. Temperatures down in rural spots where we've got some snow cover well below freezing. But then we've got these weather fronts moving in for Saturday. They contain less cold air. They're mixing with the cold air, though, at the surface, and so there's always a chance of some additional snow. But this time on Saturday, well, let's take a look at that, because it's not going to lead to such widespread snow. Mostly it's going to be rain. You can see a few flakes of snow over higher parts of Scotland, another couple of centimetres for the higher parts of Scotland. But the angle that this system's moving in, this is the start of Saturday, it's mostly bringing rain and temperatures will begin to recover. And that's highlighted here really from these temperature graphs. Let's take a look, for example, at Newcastle. Press that again. Hello. There we are. And you can see that little temperature rise into the weekend, 7 Celsius. Overnight temperatures back up to the low single figures or the mid single figures. There's London, Glasgow. So we're not seeing particularly mild air, temperatures heading back towards average, although not quite as mild as last week, not quite as cold as this week. And there's a reason for that. And that's because, firstly, there is some uncertainty about Sunday's weather. This is the European computer model. Skip forward to Sunday. This is midday on Sunday. So I talked about the weather front crossing the UK on Saturday, bringing a spell of rain. Perhaps there's some additional hill snow in the north before eventually something a little less cold moves in from the west. Then we've got another low coming along for Sunday. And this low, there's a lot of difference in the computer modelling. Now, the Met Office model looks something like this. It's got a relatively deep area of low pressure across the south of the UK, spell of rain and wind, cold air to the north. But whilst that's matched more or less in member 5 of the 50-member European model ensemble, there are a number of other scenarios that are quite different. So member 1, for example, has low pressure over northern Scotland, and this one here has low pressure over Wales, for example, and this one has it over the central part of the UK. There are differences in the track of this low and also in its depth, and that will make a big difference in terms of what the weather's like on Sunday, how warm, how cold it will be, and also where we'll see any precipitation. But as a general rule on Sunday, it looks most likely that we're going to see some more unsettled, showery weather move in, most likely rain, before that clears through. And what happens after that is that that low moves away, and we're likely to see, this is, again, looking at lots of different computer models and summarising the most likely weather patterns going into the start of next week. And here's a good way to show it. This is the top 3 most likely weather patterns for the start of next week. That's Sunday the 22nd, Monday the 24th, and this shows the top 3 most likely weather patterns. So we've got low pressure moving across the UK at some latitude and at some depth, but either way it's moving across the UK on Sunday. Second most likely weather pattern still has that low in charge, so showery, average temperatures, that's what the colours represent. But the most likely weather pattern here shows northerly winds returning after that low moves off to the east. Not likely to be wind straight from the Arctic like later this week, but certainly something a little colder coming in along the back of that low as it moves away. Then what looks most likely is that we'll have something a little quieter for a couple of days. That's what some of these projections indicate, most likely weather patterns. Nothing particularly unsettled or particularly settled. It looks like next week as a whole will be dominated by a subtle return of Atlantic weather, but not as wet and windy or as mild as we've seen through November so far, but equally not as cold as it's been this week. So weather systems moving through, but with ridges of high pressure in between, basically. Frosty nights where we've got ridges of high pressure, but a little milder when we've got these weather systems moving through. That explains why, when we look at the chart that I've shown before for the most likely weather patterns all coloured up for each day out to the next 2 weeks. There are so many colours here. It's not that we don't know what's happening at all next week. It's just that we've got various systems moving through at different times. Different computer models give different timings for those systems. So we've got a mixture of high and low at times through next week. Basically, a bit of a ridge moving in, a gap between systems, a day or two of dry, fine weather before another band of rain moves through, and so on. And that seems to be the trend through next week. Westerlies, occasional spells of rain, not as mild as last week, not as cold as this week, temperatures closer to average. What happens after that? Well, then we're into December. And just to finish off, there is something else that's happening next week that may be of interest to those of you who've been paying attention. And it's something called a sudden stratospheric warming. No time to explain all the ins and outs of sudden stratospheric warmings right now. Some of you know what they are and what they mean. Some of you might not, but there is a helpful explainer on the Met Office YouTube channel all about sudden stratospheric warmings, and we can provide a link in the description of this video. But a sudden stratospheric warming is looking likely next week, and this chart shows why. This is from the European model, and it shows the average wind speed up in the stratosphere surrounding the North Pole. Now, when the North Pole stratosphere cools through the autumn and into the winter, you get a stronger circulation going from west to east surrounding that North Pole. It keeps the cold air bottled up in the stratosphere. But sometimes you can get disturbances in that flow, and if those disturbances knock the wind surrounding the stratospheric, what we call the stratospheric polar vortex, off course, well, that wind surrounding the stratospheric polar vortex can either slow down or it can reverse. And if it's reversed, rather than going west to east, it's going east to west, well, that can rub up against our very own jet stream. And so the two are linked. There's a time lag, but the two are linked. And what we look out for is that, if the stratospheric winds reverse, then the temperature goes up in the stratosphere above the North Pole. It goes from very cold to significantly warmer. Really quite sudden warming. That's why it's called sudden stratospheric warming. And this shows the potential for those winds to reverse. So here we've got westerly winds going up in speed as you go higher in the graph, and then we've got easterly winds going up in speed as you go lower in the graph. Here's the line where the wind speed is 0, and you can see it's dropping through the rest of this month, and by the last week of November, by next week, start of December, most of the computer models from the European model show that wind reversing, a sudden stratospheric warming taking place. Why is this significant? Well, firstly, it's unusually early for it to be happening, if it happens. It doesn't often take place at this time of year, so that's interesting in of itself. Secondly, it can impact the UK's weather, not all the time, but on roughly 70% of occasions. When this happens, it increases the likelihood of cold weather in the UK. I should say, on 70% of occasions, cold weather happens in the UK. So 70% chance of a colder than average start to winter. It all depends on how the jet stream behaves and where we see high pressure building as a result of a weaker jet stream and the direction of winds, and there are lots of other factors involved. So it's not a guarantee. But when this happens, and it looks likely to happen next week, it can, 10 to 14 days later, impact the UK's weather, and it can increase the chance, for example, in this case, of a colder than average start to winter. So yes, winter's arrived early right now. Lots going on this week to focus on, particularly that snowfall, particularly North York Moors, Yorkshire Wolds, for example, on Thursday. But then could be further interesting things as we go through the next few weeks to watch out for as well. And we'll keep you updated right here at the Met Office, as always. Bye-bye.